Hi, my name is Rahul Viswanathan. I'm the CME, VP of Engineering for CME apps at Velocity. This is my colleague, Mike.
And my name is Mike Morford. I'm a principal software engineer in Velocity, and I work on Apex performance.
So we're going to present to you some of the things we have learned over the development work that we have done over the past many years on how to improve performance, how to optimize it. So we have distilled them into 6 steps, which we want to share with you today. So brief introduction about Velocity. Velocity is the leader in industry cloud software. We support 6 industries, and we are the fastest growing ISV in the Salesforce ecosystem. We have 900 employees, and as you can see, we have these many customers, some of the top names. A little bit of forward-looking statement. Before I begin, just a quick note is that you should not base your purchasing decisions. You should base it only on the products and services that are currently available. So this is the brief outline of what I'm going to talk today, what Mike and I are going to talk today. The first, the roadmap is we're going to talk about the application performance, then the 6 steps, and then the takeaways. So app performance 101. So this is a topology of a typical web application. You have a web server on the front, which is hosting the URL or the web pages or whatever. And then you have an app server behind it, plus you have all the data stores, which could be the cache and the database. So the browser makes a request, and then which is handled by the app server, delegated to the handled by the web server, delegated to the app server, which does some cache processing, cache population, and then does DB processing, DMLs, and then forms a response, which it then serves to the web server, which is then sent to the browser. Now, there are more elements to this. There could be load balancers, things like that. But conceptually, this is what is what you will see in a typical web application. Now, if you have to map this to a Salesforce application, in Salesforce, you have the app server, which we can map to the Apex layer. And in this example, I'm talking about a REST resource as the endpoint, which is used by the apps or the websites. So this REST resource is invoked to make a call to the REST resource. It's a REST call, get, post, etc. And then the REST resource handles it and then delegates it to service classes. This is a typical set of the typical patterns that you may follow, the enterprise patterns, where you have a service class which uses some utility classes. Then there could be some, there would be some cache population or cache reference. And then there is the utility classes that it invokes, which would do some DB processing, DMLs, Soquels, if you will. And then if uses, and there could be triggers underneath. So this is pretty generic flow of a Salesforce, of an application in Salesforce. So once all of this is done, then there is a response which is formed, and then that is sent back to the client, to the browser or the app. Now, in this scenario, how do you tune the performance, and where are the performance bottlenecks? So when you talk about performance bottleneck in general terms, it can refer to any of these, so any or all of these. So when you talk about performance, you say, is it quick? Does it consume more resources than needed? And when we say consume resources, it means, in case of Salesforce, it could mean Apex, it could mean heap size, DB CPU, storage, cache space, etc. In general terms, it could mean just the resources, same like CPU, DB, etc. When we talk about reliability, we say, is it durable? What is the uptime of the application? Does it go down? So we talk about reliability in terms of the uptime percentage, like 5 nines, which means 99.999% uptime is an example of the way you describe the uptime of an application. Scalability, does it scale? So if you have, as an example, if you have a lot of traffic spikes during certain events, Black Friday, if you will, then does the application scale? Can it handle the requests without degrading the performance of each request? If you apply these definitions, or just the general understanding of application performance on Salesforce, when you talk about performance, you have a well-defined set of guardrails, which we call as governor limits. The governor limits by themselves encourage efficient code because you have to adhere to the API, to the CPU limits, the heap size limits, the Soquel limits, and so forth. So when we say performance in Apex, it means per transaction, the resource utilization should conform to these governor limits. In Salesforce, reliability is you just get it because it's built into the platform. But when we talk about reliability for an application in Salesforce, it means that the application built on Salesforce is reliable, which means, as an example, you don't corrupt the data. Each transaction doesn't corrupt the data, which is affecting the subsequent transaction. So we talk in terms of application reliability and not in terms of platform reliability. On Salesforce, scalability is again built into the platform. It is a highly scalable platform where, as app developers, you don't have to worry about scaling the platform. But still, when you build the apps, when you develop Apex, and you have to think in terms of how can you tune each transaction to the maximum, which means, are we talking about tuning or optimizing the DB access or DB usage? Because the DB resources are something that affect scalability, and in general, it affects scalability for any kind of an application architecture. So coming to the 6 steps on how would you go about planning the 6 steps if you want to go about improving the application performance, given the background. So the first step is to assess, and we'll go into each of these steps, is to assess what do you want to, what kind of transactions do you want to improve? Just start off with a blank slate. What is it that you want to improve? Second is, for each of these transactions, you want to establish the KPIs, which we'll go into. What do KPIs mean? Then we have to measure and analyze each of these transactions as we keep improving and iterating over the improvements. We have to minimize the DB load, we have listed it out as a separate bullet because the transactions on the Apex transactions, if they consume a lot of DB resources, examples, Soquels or DMLs, that adversely affects the application performance. We'll go deeper into these topics. The other thing is we have to maximize on the app tier, on the Apex. So you should try to process at the Apex tier as much as you can, which means try to leverage the cache, platform cache. And finally, investigate parallelism. If performance is your end goal and you want to maximize performance, and you should explore these, if there are alternatives to make multiple parallel transactions asynchronously, and then stitch them on the client side, which again we'll cite an example. So to start with, the very first step is to assess. So we need to, first you need to see what kind of transactions are you trying to optimize. Is it a user transaction? Example, if it is 360-degree view, then you should focus on the peak response time. And if it is, which means you should minimize the processing time processing at runtime, which means the focus should be on offline processing. So you prep the data, process all the data so that it is ready for the runtime response generation in the quickest, in the shortest time. Is it a background process, batch process, in which case, as an example, if you're adding thousands of members where the user doesn't need to wait for the transaction to complete. So in such cases, we should focus on the predictable and tolerable performance. It doesn't need to happen within sub-second or whatever the KPIs that you come up with. But it has to be within a reasonable time frame, and it doesn't max out on the resource usage, which starves out the other processes that are running. And then are you optimizing for scale? If you have traffic spikes that you're trying to handle, then the focus should be on reducing DB load, because that's the most sensitive part, sensitive aspect which affects in case of high volumes. Next, you establish KPIs. So when you establish KPIs, you need to figure out what are the parameters that you want to measure and improve. Are these the response times? Is it other resources like DB usage or data storage? For instance, you may create a large number of records, which you may then have to think about archiving and so forth. But if that's the KPI, then it should be cleared out at the outset. Identify customer data shape. So at least you should know what kind of customer data shapes are we targeting. As an example, for an account, if you're creating X number of service requests, then you should try to mimic those in your test data test org, and you should create data generation scripts, and then you should have repeatable tests which you can iterate and run and measure. And the final and third step is measure and analyze, which I'll hand over to Mike.
Yeah, hi, can you hear me okay? Okay, I'm going to talk about optimizations, mostly from a single transaction point of view, meaning a single service request running on the Apex server side. When we talk about it, I'm going to talk both about trying to optimize the most obvious metric, which is how long does the transaction take to process. But we're also going to talk a bit, because it's important, about scale aspects of that transaction. Before I get into it, I have a quote from Donald Knuth that I really like. You don't have to buy into it, but I'll read it for you. The real problem is that programmers have spent far too much time worrying about efficiency in the wrong places and at the wrong times. Premature optimization is the root of all evil. I like that part. Or at least most of it in programming. Basically what this is saying is, if you're worried about performance at every step of your development cycle, you're probably worrying about it too much. At the cost of other things like maintainability. I will point out in the course of my section here the right time and place for some of these optimizations. But anyway, like I said, I like this quote. Also, before we get into it, there's don't worry too much about this. We're going to talk about a specific use case. But we're not going to dive into details. This is more just to give us motivation for doing things like reading and writing from the database. But in this example, we're going to talk about adding contacts to a campaign while applying rules, user-defined rules, for which contacts should be part of the campaign. Okay, so what are we going to look for? So I'm going to show you a list of things in order based on our experience. These things are in order. The first one is far more important than the last one. The first one, DMLs. Your writes to your database are very expensive if you take the time to actually measure the time the customer spends waiting for your DML to finish. You will likely, and I will show you an example of these being actually quite long. If you're trying to get 2 seconds, some of these can be on the order of a second. Even more importantly, for scale, Salesforce will tell you, if you try to do enough transactions in a small enough period of time, that these are very bad for scale as well as taking a long time. So anyway, the number one thing we're looking for is the number of DMLs. I'm going to show you, talk a little later about a unit of work approach designed to help minimize these. What I think about going into, say you're developing a transaction handler, I think about trying to get to 1. And the right time to start thinking about that is before you start writing a lot of code. You want to think about how can I make this transaction service a single, be serviced with a single write to the database. It's not always possible, but if it is, you want to do it. Secondly, DMLs being too slow. There's a limited amount that we found you can do about this, but one thing you can do, and Salesforce will tell you is a really good idea, is to limit the amount of work you do in triggers. Those will show up as part of the DML time. You can see them. We're going to show you a call tree later. You can actually see them if you drill down far enough and do your call tree. But again, they also, it's not just the time it takes for the trigger to run. There's also overhead on Salesforce's side that affects scale. Thirdly, too many Soquels. Don't worry too much about the details in there. But a big takeaway here, if you get to the point, hopefully all of you will, where your companies are running on Salesforce and are very successful, so successful that you're actually starting to bend the limits of the Salesforce org, what you're going to find as you work with Salesforce is if you have too many Soquels, they will start asking you questions about, well, why do you have so many? Another way of saying this, Soquels might or might not appear to take a long time to execute. Even the ones that appear to execute quickly are worth eliminating if you can. I'm not saying you can't read from the database. I am saying if you don't need to read from the database, don't do it. There's a, yeah, it says that there. Soquel's too slow. We'll talk a little bit about this. I'm not going to talk a whole lot about indices where needed. That's a common database thing. Querying only the needed fields. Some of the stuff I'm going to talk about, you might think, well, I'll just query all the fields in the table and then I'll have everything I need with just one Soquel. That's a really bad idea because some fields are very slow to query from the database, large text area fields. So really you only want to query what you actually need. And then finally, and this is last for a reason, non-DB Apex code. I have seen cases where this gets out of hand. If you've got logic errors, you could be spinning in a loop, using up a lot of time that doesn't need to be used up. What I found is those are generally pretty easy to resolve if you know how to look, generally pretty quick to resolve. And again, Salesforce will tell you if you can trade Apex execution time for DB time, it's a trade worth making, so long as the times are comparable. So that's why it's last on this list. Even so, we'll talk a little bit about how to maximize non-DB Apex. Okay, so how to look. First thing, a Salesforce debug log at fine level really does have all the information you need. Teasing the information out is not necessarily straightforward. That's the second point. We actually at Velocity, we have an internal tool for looking at execution flows. highly recommended to get something to help you visualize the call tree. Salesforce has a limited call tree view. You can only do it with logs you just captured. We found it wanting in a few places, which is why we developed our own internal tool. I will show you some of the output from our internal tool, but the call tree is the sequence of calls and the amount of time they're taking to satisfy your transaction. And we'll see some concrete examples of those. If anyone's spent any time with Salesforce logs, I think they're a little better about this than they used to be. But the first time you get a log, if you're not used to looking at logs, you need to find out whether or not your log has been truncated. If it has been truncated due to size, it can be very misleading. You can spend hours trying to figure out why this log is missing, given that there's another log there. Our internal tool actually looks for this first and just throws them away. So, another comment I hear a fair amount is how much does enabling logs affect the transaction that you're trying to measure? What I found is it definitely does affect the transaction, but for the most part, the proportionality is conserved, meaning if some part of your transaction processing, according to the logs, is taking twice as much as another part, that's usually a good indicator that the first one is worth looking at and the second one maybe not so much. Okay, next. I promised you a call tree. This is the output from our internal tool that all the information here is taken from the Salesforce log. This is a real example of a real transaction. It's modeled after the campaign handler we talked about. The first line is the entry point. The root here, you can ignore that. That's an artifact of the utility. But basically what this is telling us is for this transaction, the overall time was 6 seconds. That's actually taken from the nanosecond timestamp that's inside the logs, if any of you are familiar with them. Minor clue, if you're building your own utility based on the logs, use that nanosecond timestamp. Don't use the human readable timestamp to the left. That doesn't move fluidly. But anyway, this is saying that the overall transaction took 6 seconds. And of that, this outermost call called, I didn't count these, but like 10 things. But of those 10 things, one of them is taking pretty much all the time. The caret next to this is for expanding to see what this guy called. And I've got some highlights here. The highlight is 6 seconds for a transaction. If you've got a UI and they hit a button and it does this operation in response to that button and waits for a response, it's going to be at least 6 seconds. This is too long for most applications. I'm a developer and I want to find out why it's taking 6 seconds. Well, this tells me to expand this call. These don't matter. They're way too small. This is 4 seconds, the rest, 4 milliseconds. The 6 seconds or the 6,000 milliseconds is all in this call. So I would open this up and I would look to see what it called. The tool is capable of also showing DB operations. So if we drilled down far enough, we would start seeing things like DB reads, DB writes. But I'm not going to do that. It would take too much time. But I am going to show you another view of the same transaction, which is a summary of the database calls. So this is the same tool. It's a different page in the same tool. It's for the same transaction. And it's saying that the total time in database calls was 3 seconds, so half, which is, of course, huge. And of those, by the way, this is not complete. There are more that didn't fit on the page. There's more Soquels at the bottom. But you'll notice of the top 4 operations, 3 of them were DMLs. And this is why we talk about minimizing your DMLs. And you can also see they're very expensive. One of them took 1.3 seconds. Again, if you were trying to do the whole transaction somehow in 2 seconds, this just took up more than half of that. So you might want to investigate why it's taking that time. But even more importantly, these other two DMLs, the second line and the fourth, are between them taking up another second almost. That's way too much time. And this is why we talk about early on, figure out how you can do your transaction in one DML if possible. The Soquels, there's a fair number of them. I'm not saying that if you have to read from a bunch of unrelated tables that you can't do it. If your application has to do that, then it has to do it. But if you've got a long-running transaction and you have not inspected the Soquel sequence, there's probably a lot of reads going on that are unnecessary usually because there's an earlier read operation that already has that information. Anyway, this is the database summary, and those are the nasty bits in there. So minimizing database load, how might we go about doing it? I should have animated this a little better, but there's a key approach is called the unit of work pattern. It's published elsewhere. The idea with the unit of work pattern is you can save DMLs by doing what you need to do, if possible, in memory, and then writing only at the end. So that's why this. So going back to our example, we have a bunch of potential campaign members or contacts we might want to add to a campaign. So this is a little contrived, but one way we might do it is we might go through a validation phase where we find out, well, of my entire database of contacts, which ones have valid email addresses and phone numbers, right? So even aside from the user filtering rules, just in initial validation. And maybe I'm not so cognizant of DML, so I just write those as part of the campaign. And then I pass it to my next module, which does the filtering phase, and it actually applies the user-defined rules to figure out which final campaign members will be in there. And so in this don't scenario, it's writing those rows into the campaign for both steps. This is a very natural way to do it, especially if you've got modular code, but it's worth avoiding if you can. A better way to do it would be to validate the contacts and keep those campaign members in memory, and then apply the rules to the campaign members in memory, again, if you can. Certain kind of rules, it might be hard to do that if they refer to fields, but anyway, and then update the campaign members in memory and then insert at the end. This is the key part. It's doing one DML at the end, if you can. And this is, as I pointed out before, this is well worth thinking about before you start writing code. Can I get away with one DML? This one is a gotcha related to also minimizing DMLs. The gotcha here, this is a data structure issue. Let's say, again, playing off our example, we have a campaign member rows, and let's say we've added a parent member ID to that. Further, let's assume that we're creating both these rows at the same time. So we're writing both these rows as part of our campaign, and we're trying to minimize DMLs. Finally, let's assume this parent member ID field actually contains or is supposed to contain the ID of the other member being inserted. This is actually not possible in one DML. So it's a pattern worth avoiding. If you can avoid putting ID values into another custom field, it's worth avoiding because this ID actually does not become available until after the DML that in this example, creates Samantha Jones as a row in our campaign. Because of that, we have to, at minimum, do an update to Bertha Boxer after that initial insert, and that's 2 DMLs. And this is something I can say we have some experience with. Okay, moving on. Oh, by the way, going back to this one, the reason I brought this here, this is worth thinking about also at the start. If you're writing a data structure and you've got an ID value in there, make sure it's not going to cause you to have to make another DML in a key transaction. Okay, moving on. Reducing number of Soquels. I hinted at this before. One way to reduce the number of Soquels is you can just write your code. For Soquels, this is an example of something you can think about, in my opinion, you can think about this kind of stuff afterwards. You can just write I'm writing a feature, I need to query from a table, Apex is great for this. I'll just write a Soquel and fetch from the table. Later on, when you're trying to make your transaction as fast as possible, you might want to think about things like this. In this example, I've got one module, and it's querying from the order table the name and status fields. And then I've got a separate module, maybe only slightly related, that's querying the name and the billing address, again from the same order. Even if both these appear to execute fast, if you're worried about scale, again, if you're getting up to high numbers of transactions, 2,000 a minute, something in that neighborhood, you have to start worrying about scale, otherwise you'll get a phone call from Salesforce. If you start worrying about scale, a better way to get the same information is to combine all these. So in an earlier call, say in the first module, you would query the name, status, and billing address from the order ID. That saves you from having to do the second one. The trick here is how do you do that without sacrificing modularity? Sometimes well actually most of the time, it's a good design principle. The module 2 doesn't know anything about what module 1 is doing. I'm not going to get into details of that, but a hint is layering is your friend. Probably in that case, you don't want to be doing the query directly to the database. You want to go through maybe a utility class that is smart enough to combine like Soquels. Okay, we're going to switch examples a little bit for the next part. And again, just like the last one, don't forget the last example. We're going to go back to it when we talk about parallelism. But for now, we're going to switch a little bit and talk about a service request, where a customer calls in, gives a service request. The company to which the service request is being issued has got some assignment rules to figure out who's supposed to service this call, and then a user table gets updated with the assignment. Again, don't worry too much about the example. Here is a flow where this might look like if you weren't trying to economize on Soquels, specifically platform cache. So we might, obviously the first one is the user has submitted the request. Then we query the assignment rules that the company has configured from the database. We compile the rules, which just means put them in a form that we can actually execute them in. And then we process the compiled rules. We run the users against the service request, and we figure out who to assign them to, and then we write the assignment to the database. The little database icons are to show which ones are actually doing DB assignments. Arguably, this one could have one too, but and then we send the result to the UI. So that might be the straightforward way to do it. Of note is that there's at least 2 operations here that are querying the database. reason the assignment rules are in pink is because in this scenario, the assignment rules probably don't change a whole lot, unless there's somebody at the company constantly changing the logic for how service requests are parsed out to personnel. Probably they're pretty static. And if that's the case, a better way to do this would be to leverage the platform cache for them. So if you look at, it's a little more complicated, but it can be done after the fact. User submits a request. We first look to see if the rule is in cache. If it isn't, as it wouldn't be the first time you run it, we query the assignment rules just like we did before. We compile the rules, and then we cache them. We put them in the platform cache. And then everything else is the same. So when we went through this flow, the number of database operations was the same. But most of the time, because we put the rules in cache, the second step will result in a yes, which means, so in the second with cache step, the user submits the request. We look to see if the rules are in cache. They usually will be. We load the rules from the cache much faster than from the DB, basically instantaneous compared to reading. We process them again. We might even be able to cancel that one out, but process them again. We assign them, which is unavoidable. We have to write to the DB to do the assignment, and then we send the result to the UI. Just an example of using platform cache, but we're using platform cache to eliminate a read, which is almost always worthwhile. A quick little note on a pattern, you can look this up in Salesforce documentation. This is a cache builder pattern. Well worth doing if you believe that the result of this query is worthy of being placed in platform cache. Look up this pattern. It's a quick and dirty way to get caching. All right, getting the most out of the app tier, we're going to talk a little bit about the least important of the items I put at the beginning, but still occasionally becomes important. If you see in your call tree that you have something that's not doing DB operations, that's taking up a large fraction of the overall transaction time, then you probably have something somewhere in this category. The first one is, and again, this is something you can look up on Salesforce documentation, Soquel for loops. Basically, this is a heap management technique. The first example here is the wrong way to do it, where I have a large list of products. I just stick them in a list. I've written this code. And I do a loop that goes through that list. That's not the most efficient way to do it. The most efficient from a heap point of view is to actually use what they call, again, Soquel for loops. You can just Google it. But this is what that same pattern looks like using Soquel for loops. You just bury the Soquel query inside the for, and Salesforce takes care of partitioning out the results. Finally, in this category, eliminating non-DB logic errors and expensive system calls. Like I said, I've seen a few cases, but surprisingly few, where actual logic has driven a transaction to be much longer than it needs to be. A little more common is things like expensive system calls. Famous at Velocity are calls to describe S objects. This is a utility class call, so this is one of ours, a relatively inexpensive system call before it, and then a describe S objects. What this does is, this is a query in this particular case. It's for quote line item, and it's got a 20 millisecond response time. All by itself, that's not too bad, but you try to do this for 5 tables, which is really easy to do if you're doing something in a loop. That's 1/10 of a second. So these, by the way, are worth, you could cache the result if you absolutely need to do it and put the result in platform cache. That's a way of avoiding that 20 millisecond hit. Finally, investigating parallelism. Going back to our first contact in a campaign example, this is a sequential way of collecting all the contacts. So let's say we had a UI that wanted to show all the contacts that are going to be in the campaign. We could do it this way. This is a sequential approach where we run the filters on, say, one page of contacts, say 100 or 1,000, and we see which ones come through, and then we run it on the next and the next. We don't have to do it this way. We could try to collect all of them. But the point is the processing is sequential, that we have to run the filters on all of them in sequence, and this user has to wait while we do it. And in the meantime, we can put up a nice loading screen or the Salesforce spinner, but there's not much else we can do. If this is a relatively rare transaction, i.e. if we're not worried about taxing the Salesforce org too much, because it didn't happen too much, we could try a different approach to get a faster response time. And the other approach is to have the UI actually split. So if you'll notice at the bottom, we've got the time axis, the small hourglass, and the axis is supposed to show that this is taking much less time. But the idea is that all of the load requests are happening simultaneously. The client has basically split the request into possible contacts, and then it's run the filters on each of them separately, each in its own transaction. What this does is it leverages something that Salesforce is really good at, which is handling multiple transactions at once, and doing that in order to minimize your response time for this case. Collect the response in return. So anyway, that's investigate parallelism. The basic idea here is if you can split on the client side in this case, a large body of work into simultaneous smaller bodies of work, it might be worth doing if, again, your end goal is to minimize the response time to the user. And this is something we've done to great effect. Anyway, key takeaways. Number one, reduce DB load. It will help you with your overall transaction time, but it will also help you at scale. Use platform cache as much as you can, and optimize your Apex in general. Look at your call trees. And there's a few links with more info. You can see we're over. Q&A. Fortunately, we're the last ones. I went a little long, but any questions?
Question, have you noticed, what I've noticed, maybe other people have noticed, that the CPU time reported by the logs can be highly inconsistent? So the same code and running in the same circumstance reports different amount of CPU usage 1 minute to the next. What I usually find I have to do is I have to run the same test at least 3, 4, 5 times, eliminate outliers, and then take the average. Is that your experience as well?
I haven't noticed it. It depends on what you're talking about with CPU time, but just in general, every metric we pull out of these, I personally don't report anything without running it at least 10 times.
Yeah.
And then if I see a lot of variability, I'll run it 10 more times.
Yeah.
But yes, there is, in fact, there are times when you'll see, I've seen as large as half a second just appear. Yeah. If it's not consistent, I usually will hand wave it as garbage collection. There is, a Java running underneath that. But yes, you're absolutely right. If you want to get timings to report, you don't do one transaction.
Yeah.
Yes.
Yeah, I found CPU time, I think, is the one governor limit that's the most inconsistent. When Salesforce switched from script statements to CPU time, script statements is a very measurable thing that's not going to change per transaction, but CPU time does change a lot, depending on the transaction.
Hi. A lot of the time when I'm trying to retrieve a record type ID, I'd use the schema sObject_getDescribe, and you're saying that's pretty inefficient. Is there a better way to do that
I'm
without
s-
burning a Soquel query?
I'm saying it's expensive.
Yeah.
I'm not, sometimes there's no
There's no way
solution.
around
You should think about caching the result, put
Okay.
it in platform cache.
it. Okay.
It'll come back much faster.
Okay. I got you.
But before you do that, get a call tree and look to see, does it matter? If it doesn't matter, well, probably doesn't matter. But
Gotcha.
if it is popping up as it has at velocity, if it is popping up as a performance problem, then that's the time to start pulling those tools out.
Got you. And one last thing. Do you have an example of moving away from or moving toward parallelism? And
I'll let
I
Roll
appreciate
hold.
the last part.
So this was an example which is where we applied the parallelism, although when you example, do you mean sample code? Or,
Well, you example code, yeah, in doing
we don't have any sample code to share, but
that. Okay. Are there tutorials?
yeah.
I'm sure there are
Unfortunately,
tutorials
we don't
online
have
and
that.
everything.
Yeah.
Okay.
Batch Apex or Qubble or future methods, leveraging those.
Oh, okay. That might work.
But Batch Apex is the most obvious example.
Thank you very much.
Sure.
For debug log levels, you mentioned running fine tends to give you the information you get. Is that across all categories or just like Apex code, system, DB? Like through your experimentation,
I'm glad you mentioned that.
Yeah.
I meant to say everything default, which is info level for DB, which is really important. Otherwise, you don't see the DB operations.
Yeah.
Apex code fine is what I meant.
So you're saying everything info, but Apex.
Everything default. I don't remember which ones are none and which ones are info by default.
Yeah.
The ones that matter, as far as I'm concerned, are Apex code and the DB. On rare occasions, the system level, actually not so rare. If you want to see that get described, you got to turn system to fine.
Okay.
That's very rare. A lot of system calls will show up even if you don't change system. I think the default for system is none, but don't quote me on that. But to show that, I actually looked at a bunch of call trees, and I'm like, I know there's a get describe call here,
Yeah.
and I'm not seeing it. And then I figured out, oh, this is actually under the system switch.
So you're thinking Apex fine, system fine, DB info?
Apex fine, DB info, system fine on rare occasions, but get describe is one of those rare
Yeah, because
occasions.
obviously you need to balance the log size with all of that, right?
Unfortunately, yes. And that's been that tool we hinted at is capable of per class instrumentation to get around issues like that. So
Now this tool sounds like it's an internal only tool you use, or is it publicly available?
we are considering making it publicly available, but we were waiting for questions like that.
Can you please make this tool publicly available?
I certainly can. I've actually had conversations with my boss about this, and right now it's just sitting at legal. We have to make sure but yeah, I mean, yes, we will. I hope.
I second that, but my question is like, with the Soquels, what is the performance impact with subqueries? Because I know it's if you include subqueries, it is one Soquel limit is only one. Oh, it's only one Soquel, but what is the impact on performance when you include the subqueries?
So is the question, why should I care about a single Soquel that is
No,
executing?
actually, I was asking, is it a better idea to use subqueries rather than making it as separate? I know it's
I can't answer.
So I think, so good point. So subqueries, we typically don't use subqueries at all. And if you have a scenario where you need to use subqueries, what we have seen is using the cache as the layer instead of subqueries is better.
But to get into cache first, we can cache it later. But you have to make the call at least once, right? To
Yes, that's right. You have to make it
there is
once. Yeah, that's one way to do it. The other way is you can have an offline process which caches the reference data, not the runtime data, right? So if you have an order
Sure.
line items and so forth, you cannot obviously cache it. But if you have some product structure, some other things like campaign definition, things like that.
Anything specific you are worried, not using subqueries? You said you tried not to.
So I would say subqueries, you can use it, but I mean, we don't use it that much. But my point is subqueries, you can use it, but still the Soquel cost is the same, right? In the sense, one subquery is included as part of the Soquel. It's not
Right,
two
but at least on the limit side, it is only counted as one Soquel, so
That's
that helps.
That's right.
But I was thinking,
As Rahul pointed out, we don't use them very much, but if it's eliminating another Soquel, it's probably a win. You might want to voice that question to Salesforce, actually, because they would know since they have the actual hardware there. But my guess is it would be a win. Anything that saves, assuming your single Soquel is running from a call tree perspective, is running as fast or faster than the two, then it's almost certainly a win because there's overhead associated with making the call. So.
thank you.
You can take the questions on the side.
Okay, yeah, we got to go on the side for questions, but.